Good day everyone, my name is Narmata Ana Perempuan Manimaran and my metric number is 1040. Today, I will be discussing about 3 critical aquatic chemical processes that are used to improve the water quality. These processes are coagulation and flocculation, adsorption as well as ion exchange. Each of these processes plays a vital role in water treatment systems and contributes to the sustainable environment management. Let's move on with the first technique, which is the coagulation and flocculation. It is a process primarily designed to remove suspended particles from the water. This procedure involves 4 key steps, and let's look at them one by one. First step is a chemical coagulant such as aluminium sulfate or ferric chloride is added to the water. This coagulant then neutralizes the negative charges of the suspended particles, enabling them to aggregate. The water is then gently mixed, forming larger clusters of particles known as flocs, and the flocs is then removed through sedimentation or filtration. Chemically, the reaction for aluminium sulfate, or commonly known as alum, can be represented as follows. Here, aluminum hydroxide precipitates as a solid, effectively trapping the impurities. This process is sustainable because it minimizes the energy required for advanced filtration techniques and produces flocculated sludge, which can often be repurposed in other industries. The second process is adsorption. This technique involves the removal of contaminants by binding them to the surface or adsorbent of material. Common adsorbents include activated carbon, biochar, and zeolites. This procedure can be described as follows. The first thing is the adsorption is selected based on the specific pollutants that is present in the water. It is then introduced to the water where pollutants adhere to its surface. Finally, the adsorbent is removed, carrying the contaminants with it. For instance, let's take ammonium removal using zeolites, which can be expressed by the following exchange reaction. This method is particularly sustainable due to the renewable nature of many adsorbents and the possibility of regenerating them for repeated use. Furthermore, adsorption reduces the reliance on chemical-intensive treatments. Last but not least, we have ion exchange, which is the process used to remove specific ions from water such as calcium or nitrate. This is achieved using resins that facilitate ion replacement. The steps are as follows. First step is contaminated water flows through a resin bed and the targeted ions in the water are exchanged for harmless ions on the resin. Once the resin is saturated, it is regenerated using a regenerant solution for reuse. For example, in the softening of water, calcium ions are replaced with sodium ions as represented by the reaction. This process is sustainable due to its high efficiency, the regenerability of the resin, and minimal chemical waste. Ion exchange is widely applied in both industrial and domestic water treatment systems. In conclusion, coagulation and flocculation, adsorption, and ion exchange are 3 pivotal processes that significantly enhance the water quality. Each method not only addresses specific water quality challenges but also promotes sustainability through efficient resource use and waste minimization. And that is all from me. Thank you so much for your attention. I hope this presentation has provided valuable insights into these essential aquatic chemical processes. Thank you.